So, hello everyone, and welcome to episode 8 of our Echoes from the Field series. Today, I'm delighted to welcome Mark Rees of Echo Geo. Mark, thanks for joining me today. Could you maybe open by telling us a bit about yourself, your background in land seismic, and how your experience has evolved over projects in different industries and different parts of the world?
Hello, Mike. Thank you for allowing me to join your series of talks. I graduated back in 1985. So I've been in the business for 41 years. I joined a seismic acquisition contractor after leaving graduation, and I have spent my time acquiring data for predominantly oil and gas for a number of years. And then as things changed, there was a sort of a divergence into minerals. We stepped into geotechnical work, civil engineering projects. And I guess in the last 6 to 8 years, there's been a shift to more green energies. And we've been doing geothermal. We do some pumped storage activities in Scotland at the minute. And, there's certainly a big focus of going green in the pipeline.
Okay, thank you. What are some of the biggest challenges you've encountered when using seismic for geothermal and geotechnical investigations?
I'd consider everything that we do in the UK as bespoke. You cannot take a project from the south to the north or east to the west. It just doesn't fit. So you need to make a new model, a new design, a new way of doing things. So it's adapting to those local infrastructure issues, the landowners, the road network, and even the councils to some extent, because each one of them treats what we do with a different level of critique, analysis. Some people just let you get on with it. Some people want to know a lot more what you're doing, the planning side. So for us, it's a huge planning preparation to make these things happen. Unfortunately, the UK isn't a grid of roads and tracks that are conducive to making a survey happen. So we have to adapt and plan accordingly.
Are there any consistent themes which come across, or is it just every single project is completely unique, as you say? What are the consistent
They're all
challenges?
unique. We need to sort of avoid going cross country. English fields are small. It's quite painful to go in for a couple of shots, come back out, detouring. So it's not productive. So we try to make things happen on hard paved roads. That's good for a couple of reasons. It makes the operational window all year round. It doesn't happen in the winter when it's soft and wet. And it's obviously quicker. And, clients are looking for the best price all the time. So we need to adapt and create these routes. And it's the creation of the routes on roads and tracks that takes the time. It takes time in planning, preparation. Obviously, UK roads are full of pipes and cables underneath them. So we need to be cognizant of protecting those. And it's planning the time on roads. UK roads, for example, need maintaining. We have to share that road space with other users. So we have to plan the survey. The more work we do, the longer the lead time. But we also see that the requirements are for detailed time planning. Which day are you going to be on this road? How long? Do we need to close it? Do we need to have diversions? Do we need to notify all of the residents? It's quite complex.
Yeah, thank you. So I know you do work in geotechnical, but historically seismic hasn't maybe been used as much as I thought it might be in that industry. So based on your experience, what key benefits have you seen from using seismic for geotechnical projects, and do you believe, or why do you believe that industry should be paying more attention to its potential?
We've done many projects over the years. This is going back 20, 30 years. Site investigations They are still limited to the number of channels they typically use. They typically use small portable systems with 48, 96 channels. But what we see are requirements to image from the surface down to 1,000 meters. So we need the offset. We need a very narrow spacing. So by bringing something that we would have used in an oil and gas survey, bringing that condensed spacing, but then we need the channels, we need the source that combines shallow and deep. So multi-source operation, more channels, and also in the processing side of things, we do acquire a multitude of things, and we can in one survey line acquire, refraction, reflection, MASW, a number of things. So it's a one pass scenario for the client. So it's a cost-effective way of doing things and getting them, much more data across their site.
Do you have a rough rule of thumb of the right number of channels? I'm fairly sure it's not 48 or 96 from an imaging perspective.
No, we need to go in the thousands.
Yeah.
It's probably 1 to 2,000 is an optimum size.
Okay, thank you. And are you able to give us an example of a geotechnical project and what it involved, what the acquisition looked like, so a real project, and how the results helped your customer as well?
I can talk a little bit about a nuclear power station. We've covered nearly every nuclear power station in the country. So their remit usually is to look from the surface down to, let's say, 1,000 meters. So they're looking for any fault interference that could reactivate. And so you need, therefore, to look at a very narrow 1 meter spacing, 1,000 to 2,000 channels. But then equally, it's the source. You need something explosive for a deeper target, but then you might need a weight drop or a small detonator for really shallow components. So we often do it with a dual source, one big and one small. So, but it's getting that data, and it's what we do with the data afterwards that can give them, definitive knowledge of where the faulting is, what age the faulting is. We can do tomography, we can do shear wave analysis, we can do density, compactness, lots of things. So that data set is quite valuable.
Yeah, very very high risk if it's not done and not done right. So yeah, good to get high quality data over an area for a project like that. Talk a bit about density. So what role do you believe high density seismic plays in improving that subsurface understanding for geothermal and infrastructure related projects?
If we talk about geothermal and high density, we are constrained in a few places of where we can put sources. So to some extent, we need to balance that out with having a denser network. We may choose to put that network in quieter locations. It's urban, it's noisy. We work hard to put things in people's gardens, moving away from the noise source from the start, because if you have a noisy receiver and a low power signal going in, it's not conducive. So we like to position things to reduce noise, maximize source input where we can, but density, is key.
Can you expand on that? So why is density key for non-seismic experts? Why is density so important?
We need to get a good spatial sampling of the area. We're looking at deeper targets. Typically now we could be looking at 4,000 to 5,000 meters deep. So the survey area may not be that large, but you need to get that range of shallow far and near offsets just to make this to work. Quite often there are faults in this area. They could be steeply dipping, shallow dipping. We need to know an idea of the geology from the start to make the design, adaptable for purpose. By sampling, denser, we can then overcompensate for any noisy station. It might be noisy for this shot, quiet for the next one. But if we're sampling more, we've got a chance to, have a record that's relatively quiet some of the time in some of the places. So it's a mix of balancing what we need to achieve. We're fully aware that these urban projects are very noisy. We can't always work at night. We have to work at day. And it's silly little things like, at night people come home, they park the cars, everybody's got 2 cars, 3 cars in a household. So working on a very residential street, for example, is quite difficult. So we work on the premise that people go to work in the morning, and we've got a little working window. So we try to put the source in where we can and receive as dense as possible. Obviously, this is all budget constrained.
Yeah.
But 4,000 to 5,000 channels is quite a regular for a small job that expands upwards.
And you've mentioned some of the challenges of urban seismic projects there, and a lot of geothermal projects are urban located because that's where people want the heat if the project develops. Are there other big operational or technical challenges you see in urban environments other than those you just mentioned?
It's timing. As I mentioned, we've got some very small roads. And if you put a vibrator in a street and you cannot safely get a car past, then we have to look at closing the road. So we have temporary road closures. They have to be applied for in advance. We need to have a very switched on traffic management team. The residents, they all need notification a week before. You still get the question, how long is the road being closed for? I live on the street. Can I get past? And yes, we always allow people to go through who are residents, but the planning detail of every road by day, by the hour, where you're going to be is one of the big things that we do. And if we've got a good plan, we stick to it. We can give those people when we're coming, how long we're coming, how flexible we can be. So it makes it work.
Good planning is key. Do you typically acquire the sources at night to minimize that disruption, or is it day and night?
We do day and night. It's night in the UK is not usually carried out. It's as I mentioned, it's people park on roads, people park on the pavement. It's very difficult to get through. Plus the disturbance, although, we do pass quite quickly. It's, we do the major roads, let's just say a dual carriageway or a motorway, that would be done at night because there were different restrictions. It's how you manage the traffic management. Because we're moving relatively quickly, you need to have it on a sort of a rolling road operation. And unfortunately, that has to be done in the day because you can't operate mobile works in the dark under the UK regulations. So it's quite difficult, but it works. And, it's, as again, we come back to the old adage of planning makes the thing happen.
Yeah, so planning is very important. One other challenge some people might raise, which you haven't, is theft or people maybe not theft, but people being curious what these devices are and moving them and not putting them back. Do you encounter that as a big problem in the UK, or is it negligible?
If we're on an urban project, then theft, or let's categorize as theft, curiosity,
Yeah.
It's always a problem. I think in the recent project at York, there was something like 100, 110 stations removed. Some were removed, thrown nearby so they could be relocated and repositioned. Some never reappeared. Also, under that category, we have to think about things being damaged. So people drive over things. People didn't see it. It's buried, somebody puts a skip on it, somebody tips 4 tons of sand on it. There's every scenario you can think of, we get. But in York, we had a scheme where we offered a node in a garden scheme, and the take-up was absolutely amazing. So we had in excess of 100 gardens offering, please come, put your node in the garden. It was then secure and also quieter. So it did work.
Yeah,
But
that's fantastic. And I guess that highlights, again, the importance of engaging the community as well. So people volunteering to have a node in their garden, as you said, is safe, is secure, is quiet, probably doesn't need permitting either. So there's lots of benefits, I can imagine.
that case, it was kind of self-permitting. People were told about the scheme, and then they came to us. And then we facilitated, a time and a place when we could go and install a station. So it did work. It was very good for the PR. It's good for us. So it worked very well.
And to put those, so you said, I think 100, 110 nodes. How many were in the total project, just to give people an idea?
I think the total was 5,300.
1,000. So still a relatively small percentage overall. Good. I actually joined that project and had fantastic fun. And a lot of the challenges you've just said, I saw a particular one. I kept on coming up to, I was retrieving nodes, and I kept on finding nodes that were under someone's car. So they parked on a grass verge and unknowingly and quite understandably parked over the top of a node. But tell us more about that project. So it's a large scale seismic survey in the city of York for geothermal. Tell us from your end all about the project.
So that one at York, it's the largest 3D for geothermal in the UK. University had applied for funding to acquire that survey and to develop a new geothermal system. They've got a relatively new East Campus, which has a heating network joined to the rest of the buildings in the city there. And they're lucky to have open space adjacent to farmland, and they've got scope, and the geological setting just happens to be just about perfect for a geothermal project. So the campus is sort of centered in the middle of the 3D. They have a very tight time frame to acquire, drill, and get this all functioning as part of the funding criteria. And I think they came to us in February. We started in May, and the whole 3D, that's 30 square kilometers, was planned, permitted, shot, picked up by early November. So, it was a very quick turnaround in terms of activity in the UK. They are now on with the next planning their drill location. They're ordering all of their requirements for the drilling. The rig is sorted out. So it's all very tight timeline going forward. But, we were able to help them get what they needed in the first phase quickly, efficiently, and ultimately getting them the data they need to position that well.
And presumably they're happy with the data. I've not seen the end image, but presumably good, nice image which showed them what they need to see.
Excellent data quality. The area had been shot with 2D seismic beforehand, but it really needs the 3D in that type of geology. It's 2D doesn't give you the imaging, 3D does. So very, very happy. It's certainly focused their minds of where the target is, slightly different to what they thought and what they predicted based on using this sort of historical 2D data. But again, that's the importance of a 3D. It does give you that more certainty of locations and where to put your well, especially if you're using faulting as a conduit for any geothermal water.
It was, I love getting in the field as an aside. It was just a beautiful area to be shooting seismic. It was very varied, as you described earlier, kind of very varied land, but pretty much stunning everywhere. So it was very enjoyable to get out there. So, when it comes to selecting seismic technology for urban or sensitive environments, how important are factors like the system footprint, deployment speed, HSE performance, etc., in your view?
Just as I've covered before, timing and planning. And when we're 3 months out, we've already given the times for doing the survey. So the footprint, the compactness of a system, how you're going to do it has to be predetermined, prescribed, dated, how you're going to do it, who, what, where, months and months in advance. So the timeline is fixed. We then have to adapt and make everything happen. So we need to deploy quickly. We need to acquire as quickly as we can and to recover and get out of that. The one we mentioned in York had a time restriction that had to be completed before the Christmas market started, as there was a complete embargo on any activity on roads. So it is a very hard and fast end point. So we need to be quick. We need to plan. We need to know where to put those nodes. Well, you've seen it yourself. While you've been there, you've been out and seen the nodes. The positions where they go are to within 30 centimeters spot on to where they need to be. So yeah, it's planning and having that compactness, speed, as we mentioned on interference and theft. Everything has to be discreet. Everything we do is now stateless, so there are no markers. That didn't help you trying to find some nodes in the field, but that was but we knew where they were because they were all surveyed as they were deployed. So we call it a digital bamboo, and on all the maps have the positions. So as long as you've got a device, you know where it is. So that's the main thing that we focus on.
As you're talking about the project planning there, I just reflected to myself, it's quite amazing. I was a project manager in a past life, and hardly any projects ever run exactly to plan. But what you're describing is it has to run to plan, and it does, which is impressive. So yeah, it's kind of amazing to see in our seismic industry things running exactly to the day. It's pretty impressive.
It's something that we do very well.
Yeah.
Practiced on doing this. And if I make a plan with what we're going to do, where, when, and how, and it's amazing that the team follow the plan. Okay, you have to build in a little bit of flex, weather, and things like that. But in general, you need to finish where you say you're going to finish, and yeah, to within a matter of hours, the job is finished. It's important.
I'd highlight the crew as well. Obviously, I get to see lots of crews, and it was very, very professional, very efficient. Everyone was friendly and welcoming as well. So good HSE inductions. But yeah, people working very hard, long days, but enjoying it as well. So it was nice to see. In terms of, so you chose Stride for many of your seismic projects. What led you to choose Stride, and what benefits are you seeing from that choice now?
So back in 2016, I set up my own company, and I wanted to offer to clients the service of doing seismic acquisition. So in 2022, I saw the benefits of Stride, and actually it was 2021, late 2021. So I bought my first system. We had a project for where it was deployed, and the biggest take from everything was the fact that we could reduce manpower, vehicles, duration. Clients could phone us up and say, can you come and do a test line? And I said, yeah, just give us 24 hours, we'll be there. And literally you could go out of the door, load up 800, 900 channels, take a weight drop, go to a location, do a 2D test line just to get some parameter, some baseline measurements, and do it in a day. But if you don't own and you don't have that equipment, then you could be talking weeks.
Yeah.
of getting things. So having it on the shelf is important. Having something small, compact. And what we found when we were talking to landowners in the old days of cables, where are the cables going to go? Does it affect the cows, the cattle, the horses and everything? But going nodal takes all of that away. And I can quite confidently say today, landowners and farmers, they have no issues with nodes.
which is huge.
They're very, very happy. They just want to know where the source goes. So it going nodal helps your permitting. So even if you're going on somebody's land with a node, really, it's not an issue any longer. That's sort of gone and taken a big headache out of the way. So stride nodes, small, compact, great. Love it.
Yeah. I love you saying it as well. You mentioned permitting there, and I guess permitting is different in every country. How would you describe permitting in the UK compared to other parts of Europe? Say, is it a bigger challenge? Is it similar, or is it just unique?
Challenging and unique.
Yeah.
There are no rules, regulations where we have right of access. It's all by negotiation. If it was an oil, gas, or a mineral project, you have some land access rights. They are challenging. They are a bit costly to undertake, but for geothermal, there are no guidelines. You have to negotiate with a landowner, and so landowner access and payments, is a large consideration on a project cost these days.
As you described earlier, the size of a UK field is very different to, say, a field in the US. So I imagine unless they're all owned by the same landowner, there's a lot of fields to permit, or a lot of people to engage with just to cover a relatively small area.
And English hedgerows are pretty well, a wall impenetrable. So it's not good for speed. And it's one of the reasons why we've developed moving the source and to some extent doing pseudo 3Ds where you've got combined source and receivers along roads and tracks. It's important to be efficient. It also helps getting you the permit in the first place. And yeah, it's a little balancing act of cost, production, planning. The farmer may say, you're not coming in the field. We don't take a tractor in a field between, say, October and March. You're not coming in. So to some extent, going cross country was ruling out part of the year. So by moving things road for tracks, it does now make things a 12-month operation. So that is important that, you may have other considerations like nesting birds or in the case of York, there is a fixed timeline where they need to get their survey done. They need to get their interpretation. They need to get the drilling location. They need to organize a drilling rig. Big rigs, big depth aren't generally in the UK. They have to come from overseas. So there are lots and lots of steps that we are facilitating to make them quicker and easier and cheaper.
Fantastic. Can you share a specific project example where using Stride helped either the operational efficiency, the data quality, the logistics, or the project as a whole?
We did a little project a couple of weeks back. Client in Kenya wanted a small 3D survey. They took care of the land access on their side. They looked after our import into Kenya. So we took 900 channels, small 3D, and a weight drop. We packed up 3 boxes in the UK, total weight of 1,600 kilos, air freighted to Kenya. From leaving the UK on site through customs, 3 days into Kenya, the guys' flights were booked. She sent a team of 4. They were back in Mombasa 7 days later, flying back out. So it was deployed, shot, picked up, in and out. And I'd like to call it seismic in a box. It was quick, easy, had some local support on the ground in Kenya, but literally it's as quick as you can do anything. It's portable. It got them what they needed in that area. And within a week it was processed so they could move forward. So it's quick. Those are the things, it can make it happen. I think those are really interesting things to try in numerous locations.
Yeah, that's very cool story. So thank you for sharing that. Looking broader, how do you see the outlook for land seismic in the UK?
I've been doing seismic in the UK for 41 years. I'd like to do it a few more years. It's like anywhere, it's a bit of a roller coaster. Things become seasonal, biannual, but by mixing geothermal, mixing in geotechnical, mixing in some other sort of passive sites, we see little moves into mini 3Ds, doing surveys for railways, new pylon routes. So one may be up, one may be down, but they're kind of, by blending geotechnical, geothermal and other things, we actually keep quite busy. So it's adapting new techniques, condensing techniques into doing little mini surveys. We've been experimenting on doing little 50 meter by 50 meter patches with 440 channels in them, looking for mine shafts.
Yeah.
So there are different ways of using the technology. The Stride node gets us into places where it's small, easy to move, easy to position, but we can use that data for different things. It's not just geothermal, it's geotechnical plus.
Yeah.
It's ground investigation. And one of the things I've tried to get some of the larger consultancy groups to do is to go and do on their sites, do a big survey before they start doing anything. Quite often we go to sites and it's drill here, drill here, drill here, and nothing, then their data doesn't gel together. They've got gaps. They don't understand and they can't find out what's going on in between. I said, well, if you did a survey over your area and it only has to take a week or two, then you've got your model for your site already built, and then you fine tune, and then you go and investigate the areas that are not standard or anomalous. You can go back and investigate them. Whereas the plan at the minute is done from a desktop. Drill a whole pile of holes and then scratch your head of why they don't correlate together.
Yeah, not a good plan as it stands. So let's hope you get good uptake. And looking forward, how do you see land seismic evolving to support applications like geothermal, urban development, and infrastructure monitoring? Do you think we've already got the technology we need, or do you think land seismic needs to evolve to serve the UK market?
We've got I think, very happy on the receiver side of things. Sources are still, they haven't changed much over the years. But then it's how you use those sources. We've seen a bit of a trend on some of the smaller scale projects of using very small explosive charges. And I'm talking, anywhere between 12, 25 grams. In the right location, they really do work well. It's portable. We're not taking any large equipment across acres of land. And we are asked to go places where you can only walk. So you need to carry everything. You need to carry your source. So developments on that side, especially for the smaller scale projects, is key. But again, it comes back to that word planning. We keep drilling rigs. We can do the explosives. We've got big vibrators. We've got small vibrators. We've got weight drops. We've got virtually every resource that you can throw at it. It's just when I go to a project and I help a client, it's using my 40 plus years of experience of what can we do for them in this location. And you adapt, and you might use a little bit of this, you might use a little bit of this, but unless you've got everything on your shelf, then you are limited. But use the tools wisely, and you get a good product.
Okay, so it sounds like we've got most of the technologies we want, and it's almost your experience of what's appropriate for each location is what makes things work.
Yeah, I think the next development needs to be processing.
What would you like to see in processing? What would you like to change?
We do a lot of these small scale 3Ds, but we're doing them for clients who don't have huge budgets. So if you're having to go to a processing house to get your project I think for me, having something that is either built into a system or cost effective in terms of being able to use it, or even the use of AI. If you've got a standardized small 3D that you do on a regular basis, that there is a sort of an automated system, or even using AI to help you get an initial result. Okay, each site is different and might need some input at some point, but having that easy to use processing package, I think, is key. And it's certainly, from what I hear from the geotechnical side, it's a cost barrier for things to develop and move forward.
So it's cost, time, and automation or AI is one of the tools that can help you meet those challenges.
Yeah.
Okay, good. One last question for me. I can't be there next week, annoyingly, but you're presenting a paper at a geothermal conference in the UK. Can you tell us a bit about that?
Yeah, where there's a resource to revenue conference next week. That's been organised by the GSGB, and that's at the Geological Society on the 20th of May. Yeah, it's my experiences on the York survey of how we got the project, how we planned it, how we put it all together, showing all of the various layers of stakeholder engagement and how you make it work, basically. So it's sharing some knowledge. It's encouraging people that, things can be done in an urban environment quite easily, quite effectively. It's not going to work for every geothermal project because some are hard rock, and it's just a case of drilling a hole. But, in some locations, in some of the aspects, it is a way forward. Happy to share ideas, happy to help people, get their projects to success.
Sounds fantastic. And sorry I can't be there. I would if I possibly could. Anything else you wanted to cover which we haven't discussed today?
I think, I have to give a bit of a shout out to the Stride support team. We're quite innovative on some of the things that we do. And, Stride nodes have developed and improved. And I'd like to say that, we come up with good ideas. Your team is very responsive on making things better for not just for us, but for all of your users. So it's a big step for us is having people you can rely on and support you that are responsive and can develop something to make a new idea happen in the field.
Yeah, and thank you as well for it's good to get ideas or this isn't working quite how I wanted to, because that's how we improve. So thank you for sharing those improvement ideas as they come to you as well. How can people find you, Mark? What's the best way for them to reach out if they want to talk?
You can get me on my cell phone, or even better is an email. So that's reesm@echo-group.net. Or you can go on the website and do an inquiry. It'll come back to the office here.
Okay, cool. Well, we'll close out there. So thank you very much. There was an insightful and engaging discussion, and I hope everyone listening enjoyed it as much as I did. So thank you very much, Mark.
Thank you, Mike. Been a pleasure.
Thank you.